Okay, so what we're going to be working with today is going to be a problem regarding simple interest. All right. In case you forgot what simple interest is, it is simply that, simply the interest of a value after a certain amount of time. Okay. The formula is I equals PRT, where P is the principal, R is the rate, and T is the time. One thing to keep in mind when you're working with the rate, if you have a percentage, we're going to have to do something to it. Okay. So any percentage must be divided by 100 to make it a decimal. Okay. We cannot have a percent associated with the number. If we do, we're going to get the wrong answer. So here's what we do. We're going to go back. We're going to read the problem. And it says, Mr. Francisco is saving for his retirement. He deposited $18,000 in a savings account that pays 7.5% simple annual interest. If no additional investment is made into savings account, how much accumulated interest should Mr. Francisco expect at the end of 15 years? Okay. So I know this problem is asking for interest, and I even told you that, but it tells us in the question itself that we're going to be looking for the interest. Let's see if I can't get this thing to go. There we go. We're going to be looking for the interest. All right. So what kind of interest? Well, simple interest. And there's your proof. Okay. So what we're going to do now is we're going to see if we can't find our variables. All right. So it says he deposited $18,000. So I know this $18,000 is what I started with, or what Mr. Francisco started with. That would be my principal value. So I'm going to put 18,000. As we keep reading, we see that there's a 7.5% simple interest. This 7.5% represents my rate. And as I stated earlier, we know that we can't use 7.5%. We need to divide it by 100 in order to get it in a decimal form. Okay? So what I'm going to do is go to my calculator and divide 7.5 by 100. I end up with 0.075 as my rate. 0.075. This is the value that I'm going to use for my equation when I start plugging in. Okay. As we keep reading, it wants to know how much he'll have at the end of 15 years. Now, that's a long time to have money invested, so I'm expecting some kind of high return, okay? So what I'm going to do here is I'm going to make just a guess that letters F and G aren't going to be the amount of interest after 15 years. Because if I left $18,000 in a bank account for 15 years, I'm going to expect more than $1,000 or $2,000. Okay, so the time then is 15 years. And let's see if we can't prove what I just said correct. What I'm going to do is I'm going to go ahead and plug in my P into P, my R into R, and my T into T. So what that looks like, and I'm going to put the numbers in parentheses so that way you can see that I'm going to be multiplying them. I have 18,000 parentheses. I have a rate of 0.075. And I have a time of 15 years. Okay, so you can literally plug this equation in the way it looks, or you can put multiply for all of these. Okay, what I'm going to do is I'm going to keep it in parentheses so that you can see what I'm talking about. So in parentheses, I'm going to put 18,000, close the parentheses, times 0.075 times 15. Okay. Again, when something's in parentheses, it means that we're going to multiply it when it's side by side next to something. Okay, so I'm going to put enter. And as you can see, the parentheses turn into these little dots. These little dots mean multiplication. Okay, So as you can see, at the end of 15 years, I'm going to end up with $20,250. Okay. Now that's something that I like. I can work with that. That's something that would make me feel good about leaving $18,000 in a bank account. So let's go ahead and put our answer of $20,250. My answer is H. Thanks so much for watching. Spider-Man, tell him. Oh, that ain't Spider-Man. There you are. Peace out.